Welcome back. So for the hand-on tutorial, there's a very excellent tutorial that I always use in this case because it's very well structured. So my job is to make sure that you can, work on it and also explain to you as it goes. It's very easy to find. If you just Google this, Deep Learning with PyTorch, a 60-minute blitz. I can actually send it probably on the Slack. Hello. Okay. Yeah. So I sent the link on Slack. I did send also a link to a directory on Fugaku. Does everybody, I assume, since the morning, you know how to log into Fugaku? Can you? Right? Okay. So if you go to that directory, basically this opens for you the tutorial. This is on the web. It's on PyTorch website. And that directory here is, you need to go to that directory, right? So after you log into Fugaku, you do cd, change directory, space, and just copy paste this. You will go there. What you will find in that directory is something that looks like this. I should probably increase the, I guess it's small, increase the font. If you copy, once you go to that directory, the path I give to you, so LLM, like list, it shows you what's inside the directory. So you should be seeing all these, right? Those are the Python files from this tutorial, right? Plus the data setup and everything set up for you, basically, right? You should start from this, setup.sh. If you write cat, setup.sh, shows you the instructions, right? This is how to get an interactive node on Fugaku. I think you learned that in the morning. Not. So you need to do this first. This allows you to say to Fugaku, hey, don't log in and just use right away. Get an interactive. Interactive means you're telling Fugaku, job scheduler, give me one compute node. I will run code now. This is what you do, right? And then you need to do these two commands, right? And make sure you copy the directory to your working directory, right? That file, you don't have to look here. You have it in your directory. Just open it. This one. It's called setup.sh. If you get stuck or this is too much for you, tell me, raise your hand. I'll come to you and explain again. Okay? Don't be shy. So this is just a setup for it. Now, what this tutorial is about, again, PyTorch is one framework that is used in AI. So if you happen to be, developing models, using models, want to train models, want to fine-tune models, there are many frameworks. PyTorch is just one of them, and we happen to use PyTorch for the purpose of this. Fugaku is set up, and there's one line you have in the tutorial folder that allows you to prepare for you the environment, so you don't need to be writing complex things. It just works out of the box. So what is in this tutorial? If you work through it, right? It has 4 different things. One, it tells you what exactly is PyTorch. What is the representation of PyTorch? What does PyTorch do? PyTorch, as the name implies, is in Python. It is a Python interface or Python wrapper for Torch, which is, again, a framework for AI. Presents everything as tensors. Okay, tensor is unfortunately an overloaded term. Tensor has some meaning if you come from physics, it has a meaning, but in computer science it has a different meaning. The very short description, very simple short description of a tensor, if you're a computer scientist or a programmer, it's a multi-dimensional array. That's it. If you don't know what a multi-dimensional array is, ask me, I can explain, or just raise your hand. An array, I guess everybody who programs, an array is just a data structure in a programming language. You put data in. It's very regular shaped. It could be one-dimensional array, that is one single row of values, like a vector, It could be a two-dimensional array that looks like a matrix of values, x and y. It could be higher dimensional. It's called multi-dimensional array, like 3 dimension, 4 dimensions, 5 dimension. It is, in the end of the day, a data structure that is defined to hold values, and it is very regular, right? It's why they use in programming, because this is how you process numbers. You put them. Why does AI represent everything as tensors? That's because the mathematical way, the easiest way people found to process all the mathematical operations in a neural network is to represent everything as tensors, and you apply on it what's called dense linear algebra. That is, you're just multiplying matrices together. If you're not familiar with multiplying a matrix, just take a fast look on Google. You should have, as a kid, seen it. Anybody, even if you're, you're not using matrices and so on, you have seen them somehow in your life, I guess. Take a fast look on Google to remember. Multiplying a matrix with a matrix is just 2D representation of number, 2D representation, you multiply together. It's a very simple, primitive operation. Yet it is fueling or powering all of the innovation happening in machine learning, because they took down all this complex representation of neural networks and connections and activations and all of that to just a series of matrix multiplications. That's it. No more, no less. There's some also, of course, there's some nuances and subtle points you should be aware of, but at the end of the day, by and large, it's just multiplying matrices. And actually, this is what makes it actually very, how to say, people were able to very fast move on the AI side, because if you represent everything as just simple dense linear algebra or matrix operation, then it becomes easy. Peter went to sleep. Anyway, so everything is represented as tensor. So tensor, PyTorch allows you to define a tensor. Like in this case, this is a 2D tensor. You're saying, create for me a matrix that has a value 1, 2, and 3, 4. And when you type this command, it gives you that, right? If you're familiar with Python and you use what's called NumPy, NumPy is a package in Python that allows you to manipulate numbers, crunch numbers, do a lot of operations on numbers. You don't have yourself to implement operations, you just use it as a user, right? PyTorch allows you to move numbers back and forth. So this is very, simple things. Of course, there's the shape of the tensor, there's the type of the tensor, where the data is stored. Why is all of that important for you? Well, it's important if you want to construct a neural network to know what a tensor is, right? So what I suggest is move down this tutorial, start reading it. I don't want to read for you every single sentence. I want you to do it on your own. And if you get stuck at any point, tell me. And then the files you have in your directory should help you to go through it, right? So there are different tutorials here. If you look at this folder, there's the first one, which allows you to manipulate tensor. One is you make a neural network, and the third one is you train a neural network. So you have three different components or programs in this tutorial. And for each one of them, there is a command for you here that explains to you how to learn this program. So to give any example, let's open this file here, the first one. So this is a Python program that is combining all basically it's collecting for you all the tutorial part which you should walk through in one place. So this looks like a Python script, Python program basically, right? And it allows you to make a tensor, multiply a tensor, transform a tensor, do all operations you can on tensor, right? And if you want to run this one, right, the instructions are here actually. This is how you submit it. You should run this JavaScript, right? What you need to do is basically sh and submit. Again, I know that in the room many people are not computer scientists, so again, if this is too much for you, tell me, I will come to you and be easily happy help you with that. So what you need to do is basically, in the time of this, read through this, and after you finish, you can go there and execute it to see the output, right? So you don't need to write code yourself. Of course, you're very welcome to manipulate and change the code if you want, if you're advanced enough. If not, it's fine. This is the first program. The second one is that one we could skip and go to the third one. So we're basically doing the first one and the third and the fourth. Or you use PyTorch now. If you can, in the first example, you can create tensors and manipulate them. Here you can create neural network, which is a composition of tensors, basically. And that shows you how a neural network is made. You can even look at the code and see you make one layer. So a model looks like this. That's a set of layers, back to back. So the model is creating layer after layer after layer. You ask it to take the training data set, do a forward pass to compute the loss, and then a backward pass. And your output is what the model looks like, basically. The last one you'll be looking at is how to train a model. So you basically have three things today. How to create tensors and manipulate tensors. And then the second one is how to make a neural network out of tensors. The last thing, how can I train a classifier? How can I train a model to take images like this and predict, so that the model can predict correctly what an image is. This is a very simple neural network, like a very simple example, actually. Right? This was actually fairly complex years ago, like 10 years ago or 8 years ago. Now, just as you see, it's just a toy example. And as the model proceeds, it can train on you. It trains your model on Fugaku. So to repeat, please start from here, read down that, and an explanation, and to run the code. Again, the folder you have access to will have all the training scripts, and this file in specific gives you everything. And the code examples on this homepage, I already prepared for you in files here. So you can see the three examples we have today. How to create tensors and manipulate them, how to construct a neural network from tensors, and then how to train a classifier. Right? Again, give yourself time to read through the PyTorch Blitz tutorial. It's very informative. It's very simple. And it's very interesting that even from simple things like tensors, you can construct very complex neural networks all the way up to LLMs and complex LLMs using that. So it's a very good tutorial, actually. Even if you're not yourself developing models or AI technology, but just a user, it's actually very nice to know a little bit about how these models are constructed. Because once you know that, it's like driving a car. You can drive a car and just, know how to just operate the car, but it's also nice to know a little bit about how the car is made and the engine and fuel, cycle and everything. So to clarify, I'll write the exact step so you can just copy paste to make it easier for everyone. The steps as follows. First, you need to make sure that you have this directory. This is a tutorial directory, right? That is on your working directory. Once you have that, you should. Okay, so I think this is the simplest way where you can copy paste. So first, from your working directory that you copied the tutorial, right? First, get an interactive Fugaku node. You should run this command. It will get you a Fugaku working node. And then there are three programs. You can run any of them in any order you want. This is a command to run the first program, the command to run the second one, the command to run the third. You want to learn the program itself to understand. The description of each program is basically on those pages. So try this in sequence. If you get stuck, then please just raise your hand. I'll come to you. I think it's about time to wrap up. Thank you, everybody, for your staying through lecture and then the hands-on. I know it's very hard to cover a lot of substance in a short time, so apologies if some of the parts would not explain well, and I went through them fast. I shared my slides. You'll find them on Slack. You will find me on Slack through the duration of the school. If you're interested in talking more or chatting, you can always reach me by my email also. Thank you, and enjoy the rest of your school.